We did, because we replaced x with 2 theta, but x is equal to theta over 2. Did you guys catch what I'm saying here?
Yeah.
Okay, so we got to, I'm going to kind of like, take out everything after we found what x is. So what we really found was that theta over 2 is equal to pi over 2, or 3 pi over 2. And likewise, theta over 2 is equal to pi over 3, or 5 pi over 3. So how does that change our answers? What does that make theta? Well, no, so now, so yesterday we divided by 2 because we had that backwards, right? Pi, 3 pi, pi over, 2 pi over 3, and 10 pi over 3. And then if I wanted to make things just a little bit worse, which values of theta were we looking for? Between 0 and 2 pi, so I'm going to go ahead and knock off those two because those aren't in between 0 and 2 pi. That's my bad, y'all. I promise that is the first of what will be several mistakes throughout the semester. Arguably many. I'm not perfect, and especially with, the more complicated math. Second semester is even going to be worse. Everybody good? Yeah, great. Grunt if you feel good about it. Okay. What do you guys remember about inverse functions?
Opposites.
When you say opposite, like if we're talking about like mathematical operations, addition and subtraction are inverse operations. Okay. An inverse function is a little bit more than just opposite. It's essentially the working backwards, okay? And so, like the basic idea is I put a number into a function, I get a new number out, right? If I plug in x, I get a y. The inverse is where I will plug in that y and get this x out, the same number back out, okay? And so, essentially, if you do both functions, your result should always be the same x answer. Okay, so if I want to verify that two functions are inverses, what I want to do is take the answer to one function and plug it into the other one and end up with x. In other words, I want to find the composition of those two functions. Everybody good so far? All right, and so if I did that here, I would do 5 times x minus 1 over 5 plus 1. And if this simplifies down to x, then I know if I plug x into the one function and then take that answer into the other, I'm getting that same x out every time. That's lovely. That's what we want. Okay. So is that what works out here? The 5s would cancel, yeah. Now I have x minus 1 plus 1 is x, so check. They are, in fact, inverses of each other. Now, let's do this. Poor Charlie's not going to be able to see this at first, but I'm going to do a screen capture. It'll work out just fine. I'm going to go ahead and graph these two inverses. All right, so basically what I'm going to be doing here, no, I still want this centered, is what I'm trying to point out here, just an easy screen capture. Perfect. This is all right, so here's my graph of these two equations. You guys can kind of see it, yeah? All right, so what I want to point out is the symmetry of the two equations to the line y equals x. Okay, so like this point, and this point are the same point. Do you guys get what I'm saying? Like because they're just the x's and the y's are flipped. So you always have that symmetry over the line y equals x. Okay, because that's going to come into play on the next page quite a bit. Okay, great. All right, so let's go ahead and look at, why don't you guys try this one, where you're just showing that these two are inverse functions. Everybody good? For verifying, it will stay this simple. That doesn't mean the whole thing's going to stay this simple. Okay? Everybody good? All right. So let's move on to, and we're going to do kind of a little bit of a sidebar here, okay, before we actually work these questions. All right. So this is not, you don't necessarily need to write this down. You just need to understand why it is the way it is. Okay. So when we talk about inverse trig functions, in a regular trig function might be y equals sine x. Everybody good? All right. And what does the graph of y equals sine x look like? Give or take? Great. Give or take? Great. And right now, x is an angle, and y is the value of that trig ratio. Everybody good? So the sine inverse y would be the angle and x would be the ratio, yeah? And when we think through that, the fact that we're switching the x and the y, it might now start to look like this, yeah? And like that, almost like a doctor's pole. It's starting to look like one, yeah? Are we okay? Because I flip-flop those, right? It kind of like bumps everything up to the y-axis instead of the x-axis. Okay, now, I'm calling these inverse trig functions. Is the second graph a function? The y-axis alone fails the vertical line test, yeah? Okay, so what we have to do for inverse trig functions is we have to limit the domain in the range. Okay, So when we talk about inverse sine, we're going to zoom into just this part of the graph because this section of the graph
Still function.
is still a function and it covers all the possible y values. Okay? So for inverse sine, and this is the part I might write down, is for the inverse sine of x, okay, your x coordinate, so your domain is -1 to 1. Your range is essentially the angles for this box, yeah? The angles that define that box, which is -π/2 to +π/2. Are we good? All right. So if I shift this to cosine inverse, well, cosine of x versus cosine inverse of x looks like this. That's a full period of cosine. It's still not a function, so we're still limiting our domain, but we still want to have every possible angle as an answer. Okay, so what in this case what we have to do is zoom in on, say, this section, because if I zoomed in on the other section, I would only have the right hand side of the graph, so I need to have both the right and the left. Everybody good? Okay, so for cosine inverse, my domain is -1 to 1, but my range is 0 to pi instead. And that will still include every possible kind of result on the unit circle, kind of. Both positive and negative result. Okay? We good? Okay. And then similarly to sine, tangent x, or tangent inverse of x is -1 to 1 and -π/2 to 2, π/2. So, and the basic premise is, so like if I look at if I'm trying to like use a calculator to calculate the sine inverse of √3/2. Well, yesterday we kind of talked about the sine inverse of √3/2. We had a bunch of answers, right? So sine inverse of √3/2 was π/6. It was 5π/6 if we wanted to go around again. Like there was lots of different answers. But when we talk about inverse functions, for something to be a function, you plug in that √3/2, you can only get one answer back. Okay, so the answer so if we're talking about this in the framework of what is the arctan of square root of 3 or the arcsine of square root 3/2, since we just talked about that one, the one we want is π/6. Because that is of the possible solutions, that is the one in between -π/2 and π/2. Whereas 5π/6 is bigger than π/2, so we don't want to include it. You guys did this in pre-calc, but it was a really long time ago. Are we comfortable with this? All right, so what is the arctangent of square root of 3? π/6? What about arc cosine of 2? Oh, that's a typo. You know what? We won't call it a typo. Is there an angle where the arc cosine is equal to 2? What's the range? What is the input, or what is the domain of arc cosine? Between -1 and 1. So can I plug in 2? No, because 2 is outside of the domain. So that one's not possible. All right, what about arc cosine of -1?
Pi.
Pi. Because that's where cosine would equal -1. From the unit circle perspective, in order for cosine to equal -1, in order for cosine, not arc cosine, for a cosine to equal -1, the x-coordinate has to be -1, which that angle is pi. Keelan, you look unconvinced.
The inverse sine one, the root 3 over 2, should that be pi over 3?
Oh, it sure should. It sure should. You were the ones that got it wrong. I just wrote down what you said. You notice my cheat sheet's not in front of me. Are we feeling okay? Okay, cool. Do you guys like this one? No? All right, so if I wanted to define the inverse, it would be, I would take each of those points and switch them. So now if I'm saying the inverse of 8, I'm saying in the inverse function when x equaled 8, what was the y number? So what's the inverse of 5? 3. You feeling good? Is all that's left. All right, you guys, from here on out, I'm going to give you a choice. Would you rather work on your homework and get up to date, or would you rather me do these notes and then tomorrow's a homework day? Notes and then tomorrow work on homework?
Yeah.
Great. So we're going to talk about some logarithms and log properties today. For this section, I'm certain that you guys forget a lot of log properties. We end up using them a lot more in this class than you did in AP. And we might even talk about a couple extra ones, okay? You guys, help me out. You guys have your calculators, right?
Yeah.
All right. Can you guys tell me, you guys know how to do the log base where you can do like log base 2 of another number? Like you can put in whatever base you want. I think it's alpha. It's in the math menu, but I think if you can do a shortcut that's alpha A.
Which is math. Alpha math. That just typed A. Yeah.
No, you gotta click that first.
No. If you hit alpha and then the window button.
Oh yeah, and that's 5.
So it's a little bit quicker.
Yeah.
I don't know if it's a lot quicker, but it's definitely a little bit quicker. Okay, so what I'd like you guys to do is log base 2. No, I lied. I would like you to do 2 to the log base 2 of 3 power. Yeah, math A, but if you hit alpha window, you can get, it's one less keystroke, that's all. Everybody good? What's the answer? 3?
Yeah.
Should be just 3, yeah?
Yeah.
Okay. How about 5 to the log base 5 of 7? And you get 7. Okay. You guys, if that is the case, what is e to the natural log of 8?
8.
Everybody good? Okay, so that's a log property that is not one I don't think she talks about it in pre-calc, or if she does, it's really that is a property we're going to use for some proofs later on that I want you guys to at least be comfortable with. Everybody good? Okay. All right. So if I ask you guys to graph y equals 2 to the x plus 3 power minus 2, you can do it in your calculator. If you know what it might look like, great.
Should we draw the graph on our paper?
Yeah. I would imagine it looks something like this.
Yeah.
Ish. And you guys, if I asked you what is the domain of this graph, what would you tell me? Negative infinity to infinity. I totally agree. And the range? And we're comfortable with where those numbers are coming from? Okay. All right. What about y equals log base 4 of x? What might that look like?
Bless you.
Oh my goodness gracious.
It's now a good time.
A lot of.
Just want to come back.
No, I'm making them do something real quick. Is it a quick conversation?
You have kids? No, I'll come
No,
back.
no, no. They were gonna have work time. They chose to do more notes instead. But
You sure?
they can. You guys can work on this for a second, yeah?
Seriously.
Hey, good luck on the next question. Let's see how you do with it.
Oh.
You're just saying for like an hour.
.151, if I am correct. 152.
Did you put the on that? Did you just
Center
paste
is,
it?
doesn't work for this technical number.
Oh, I have a problem, don't I? I think there was a typo in this. Did I fix it? I definitely have a typo in this.
Oh.
For the second one. See, I should have the cheat sheet out for when I also, because typos are also a major problem. Guys, think through the formatting of all this stuff for this. It's a lot. Yeah,
Was there a typo?
there is a typo. We'll do this one. I'll tell you the typo in a second. Domain,
Uh,
0 to infinity, range. We good with these? Do you guys see that logarithms essentially, like when we look at these shapes, logarithms and, now, are these two exact inverses of each other? No, but in general, logarithms are inverse operations of exponents, and exponentials are inverse operations of, okay? And so one of the reasons logs feel so uncomfortable is because it's like undoing an exponent. It's like a weird notation. It's not quite the same idea. But is everybody good with this idea?
Wait, should the graph be going down to infinity?
Yeah.
Because I have mine's
Mine's not.
I accidentally
Yeah,
deleted it.
mine doesn't either.
Mine stops at like negative 1.5.
Okay, hit.
Mine's doing the same thing.
Yeah, mine too.
So, where is that? Let's go to
They
formats.
done all these four.
Nope, that's
times.
not it.
Yeah.
Okay. I was like, did I type it in wrong?
I was like, do I have to do anything with this graph?
There's a way to do this. If you hit window and scroll all the way to the bottom, it should say delta x.
Mm-hmm.
Make it a really small number, like 0.002 or something. At least that's not really small, but
Making it really, really small.
It just-
it's gonna go slower now, I would
can't
think.
see anything now. It just made my graph disappear. Wait, did I hit something else too? Wait, no?
That, I don't know if that's right.
That didn't work?
No, I don't think so.
It makes your window
In
really weird.
error
Yeah.
window range.
Is this what it's like?
It comes up when I do that.
That's all.
Like, it makes my window
Yeah.
Alright, so that was the wrong thing.
Maybe it needs to be a really big number.
It doesn't.
Yeah, no, this is what.
I
Yeah, not it. I don't even see the graph.
There's some lines on the right side.
No, but I'm saying the actual.
Oh, yeah. So yeah, since. Oh. Or throw it back to this measure that should be.
Why did it change my x max? It went from 10 to 9.97.
Yeah, that's what mine's doing.
it changed your x max to.
It changed my x max.
So changing the delta x at the bottom.
Wait,
Yeah.
wait. It changed. Yeah, changing
I
delta
think
made my x max go from 10 to negative 9.97.
Yeah, that's what mine's at.
If
Mine's
you try and
at
teach the
negative
window back,
9.9.
Charlie gets to listen to our crisis right now.
There is a way to do it. So, like, I can tell you what's going on. It's in the same way that it's similar to, but not quite the same as the idea that you never actually see it. Like the operationally, like this is getting closer and closer and closer, right?
Yeah.
To the point that your calculator can't show it, and it doesn't do a great job when it's along the y-axis. Like on the x-axis you can kind of see it, but it does definitely go down forever. Okay, because so if we think about this as this is the equivalent of 4 to the y equals x, yeah. Okay, and so we could build that xy table, like if I had to graph y equals 4 to the x, like we go way, way, way back, right? Like when you guys first learned about exponentials, you might have had this and then you said, well, if I plug in -2, I get 1/16. If I plug in -1, I get 1/4. Yeah? And since these are inverses, for every x I can put here is a y I can put here. So if this if negative 2 1/16 is on y equals 4 to the x, that means its corresponding point for the logarithm would be 1/16 negative 2. You with me?
Yeah.
Because they're inverse operation, we flip them. Well, could I have on this graph negative 3 1/64? Negative 4 1 2/56? We could, yeah. And then, so for all of those, and what's happening is your calculator can't, it's getting so close to the y-axis, your calculator can't differentiate.
Yeah,
That's what's happening
yeah,
there.
It cuts off if I zoom in, it cuts off at
Which is,
0.27 and negative 1.12.
so I'm going to figure, I know that there is a way where it doesn't do that. I'll do some research and have it for you guys for tomorrow. But this is one of the reasons why we also use analytic techniques to solve limits. Because if we looked at your calculator, you guys would say the limit doesn't exist at x equals 0, when in reality it is So there's reasons why we also have other methodologies for doing those kinds of things. Everybody good? Okay, now, as for this one, the typo was that this minus 1 was not in the exponent. So this should have been e to the x minus 1. And then showing the inverse operation would be the fact that they're inverses might be a little bit easier.
It was just e to the x minus 1, not e in the exponent. Okay.
The minus 1 isn't the exponent. So you guys, what is e to the natural log of x plus 1? X plus 1. Based on that property we talked about up top. Minus 1 is x. Okay. You guys, what's the natural log of 1? Remember that saying e to what power equals 1? That's what that would mean, yeah? And in fact, any log of 1 is 0, because that's the exponent to get to 0. What's the natural log of e? 1. When it comes to like natural logs, or when it comes to logs where these are the kinds of ideas where you might get a whole number answer, I would expect you guys to kind of make sense out of that. Okay. I feel like I can't get my neck to crack enough. I think it's the early mornings that it's not really my neck needs crack so much as I can't fall asleep early. Yeah. Okay. Oh boy. You guys ready to do you guys remember doing expanding and condensing?
I remember doing it, but
Don't remember the rules? Okay. All right. We're essentially going to be using 3 different rules. Okay. So let's say I have log of 2 things being multiplied. So these correlate with exponent rules. Okay, a reminder that logs are exponents. So that is the equivalent of log of 1 plus the log of the other. Multiply means I add my exponents. Likewise, the log of m over n. Division makes me subtract my exponents. And then lastly, he's engraving calculators.
That makes more sense.
It's n times the log of m. You can bring an exponent down because when I have an exponent to another exponent and multiply, yeah? Okay, so knowing that, I could take this, I would start by maybe calling this the natural log of 3 plus the natural log of x squared. Which then becomes the natural log of 3 plus 2 natural log x. Everybody good? Why don't you give this one a shot? I try. Yeah.
No, Charlie.
What?
We got our folders back today.
For what?
Singers.
What about it?
You got one?
No.
Just give it a second.
Okay.
Do you remember our little blade stickers?
Maybe.
It's been one summer to forget.
Anyway, you just rare.
Unless Greg has took them all off.
Hey, Charlie.
So.
It's recorded the rolls and stuff. It's good
Thanks
guy.
for coming good with that.
So if there's no Schoology course for this, can you just like email me the recording?
Yeah, that's usually what I do.
Thank you.
Or if I forget, because like a lot of times I'll get it uploaded and then be running around. I have a YouTube channel. It's like Mathmeister or something like that. That's where it goes straight. It goes straight to the YouTube channel.
Thank you.
You will have access to Blackboard soon, but I usually just email it to people who need it.
Alright, stick with four.
Thank you so much.
Charlie, because I'm going straight into AP, I might forget to upload the recording. I'm gonna try to do it over lunch. If it's not there after lunch, just shoot me an email so I can do it 8th period, okay?
Okay, cool.
Because I definitely won't remember an 8th period. There's no way.
So many people.
Thank you.
I'll see you in,